viewers, welcome again to Mathematics and It's the presenter Jeff Nino, and today on the board we shall be looking at how we can solve problems on differentiating trigonometric functions. Okay, in our previous videos we looked at how we can use chain rule, quotient rule, and product rule in solving some functions. But today we have 4 questions on the board, and the question says find the derivatives of y equal to sin 10x, y equal to 7x cos 4x, y equal to sin x cos x, and y equal to cot x. Now, with the end of this video, you shall know how you can apply either chain rule, product rule, or quotient rule in differentiating trigonometric function. Now, if this is the first time in joining us in our channel, you are welcome. Please don't forget to subscribe to our channel and don't forget to share our videos. Okay, without wasting time, let us begin the class. Question number 1 says y equal to sine 10x. Okay, when you have a question like this, what do you do, or how do you go about this? Now, first of all, you will notice that in this question, I have just one function, and the function is 10x. Okay, now we said in chain rule that if chain rule has just one function, and that the name of the function is u. So if our function here is 10x, it means our u is equal to 10x. So here becomes u is equal to 10x. Now, if u is 10x, it means y is equal to sine u. How did I get this? We just said 10x is the function, and the function is u. So if 10x is u, writing the question again, it becomes y equal to sine. Instead of us writing 10x, we will now write u. Now, when you are done with this step, the next thing you are going to do as a student is to take the derivative of u with respect to x. And this simply means du over dx. Now, here becomes du over dx. Now, if I differentiate 10x, okay, I will get 10. Now, here we will take the derivative of y with respect to u, which is dy over du. So here becomes dy over du. Now, if I should differentiate sine u, I will get cos u. Okay. Now, after the second step, the next thing we're going to do is to introduce the formula for chain rule. Now, the formula for chain rule says dy over dx is dy over du times du over dx. So what does this mean? It means this is dy over du, and this is our dy over du. And dy over du is cos u. So it means in place of dy over du, I will give cos u times, now d over ds, this is d over ds, and we have 10. So here becomes cos u times 10. Now, cos u times 10 will give us 10 cos u. But now we are not done with the sum, because we said from the beginning of the math that u is 10x. So automatically substituting 10x again for u in the final answer, we have 10 cos 10x. So this becomes the answer to the question if we should differentiate y equal to sine 10x. Now, for some student writing exam that does not have lots of time, instead of going through this, we can apply a shortcut. Okay, now the shortcut is solved this way. Imagine we want to solve this question now in seconds. This is what you are going to do. Simple. First of all, differentiate the function. Now the function here is 10x. If we differentiate 10x, we will get 10. Now, differentiate the trig sign. Now, the trig sign here is sine. Now, if we differentiate sine, we will get cos. And then what do you do next? Copy back the function, which is 10x. So you will see that the answer we got when we use chain rule and the answer we also got when we use a shortcut is the same. So any of this method you can apply in solving this type of question, and you will still get the same answer. Okay, all right, without wasting time, let us go to question number 2. Question number 2 says, y equal to 7x cos 4x. 7x cos 4x. Now, when you have a question like this, the first that comes to your mind is, now we have 7x cos 4x. Originally, imagine you have something like this. xy, or you have 2x. Now originally, xy means x times y, and 2x means 2 times x. So it means before xy came together, it was formally x times y. Now, also in this question, before 7x cos 4x came together, it was formally 7x times cos 4x. Now, if you say 7x times cos 4x, it originally means that in this question, we have two functions. Now, the first function is 7x, and the second function is cos 4x. And we said in product rule that when you have two functions, and that these two functions multiplies each other, you apply product rule in solving that type of question. Now, without wasting time, let us apply product rule in solving this question. Now, in product rule, you have two functions, and the functions' names are u and v. So it means that my first function now is u, which is 7x, and my second function is v, which is cos 4x. Now, applying our product rule says dy over dx is u dv plus v du. Now, u dv means hold du differentiate v, and v du means hold v differentiate u. Now, without wasting time, we have this. If we hold u means don't touch the function of u, just write that. And the function of u is 7x. Then open the bracket. Now, we're going to differentiate v. Now, v is cos 4x. Now, cos 4x alone is a chain rule question because that's just one function, 4x. And we said we can use the shortcut to solve this problem. And how can we do that? First, we differentiate the function, which will give us 4. We differentiate cos. When you differentiate cos, you get minus sign. So the minus is here, and your sign is here. Then you copy back the function, which is what? 4x. So it means if I use shortcut and differentiate cos 4x, the answer we will get is minus 4 sine 4x. So in the bracket, I have minus 4 sine 4x. So we have differentiated what? Cos 4x. Now plus. Now what am I holding now? I am holding v as constant. Now v now is cos 4x. Then what am I differentiating now? U. Now our u is 7x. Now if I should differentiate 7x, we get 7. Now the next thing for us to do is to open the bracket. Now 7x times minus 4 sine 4x will give us minus 28 sine 4x plus 7 times cos 4x will give us 7 cos 4x. Now in case the options are not like this, what we're going to do is this. Simply bring the answer with the positive sign to the front and the answer with the negative sign to the back. So finally we're going to have 7 cos 4x. Now the back becomes minus 28 sine 4x. So this becomes the answer when we apply product rule in solving 7x cos 4x. Now this is the answer to question number 2. So without wasting time, let us go to question number 3. Question number 3. I hope you are learning something. Yes. Please don't forget to subscribe to our channel and don't forget to share the video so that others can learn from it. Okay, question number 3 says y is equal to sine x cos x. Again, sine x cos x originally means sine x times cos x. And so it means we are again applying product rule in question number 3. So it means our first function now, which is sine x, is u, and my second function is v, which is cos x. Again, applying the formula which says dy over dx is u dv plus v du. And we said again that u dv means hold u differentiate v, and v du means hold v differentiate u. So without wasting time, my u is sine x. I will hold it. But I will differentiate v. My v is cos x. If I differentiate cos x, I will get minus sine x. That is all. Now, plus. Am I holding what? Am I holding now v? I'm holding v. Now, if I hold v, v is cos x. And when I differentiate u, u is sine x. When you differentiate sine x, you get cos x. Close the bracket. Now, the next step is to open the bracket. Now, when we open the bracket, we are going to get this. Sin x times minus sin x will give us minus sin square x plus cos x times cos x will also give us cos square x. Again, the answer with the positive sign comes to the front and the answer with the negative sign goes to the back. So here becomes cos square x minus sin square x. Now, it could be that in the options, there is nothing like this. Now, this is as a result because you lack the understanding of compound angles. Now, go back to our previous videos in our channel, you will see a video that talks about compound angles. In compound angles, cos square x minus sin square x is equal to cos 2x. For you to understand what I did, you have to go and study compound angles. When you do that, then you know what I have done here. So this becomes the final answer to this question. Now, this is question number 3, and without wasting time, let us go to question number 4. Now, question number 4 says, question number 4 says, y equal to cot x. Cot x. Okay, now first of all, what is the meaning of cot? Cot is the inverse of tan, which means 1 over tan. Okay, it means 1 over tan. So without wasting time, it means wherever we see cot x, we would include 1 over tan. It is the same thing. So here becomes y is equal to 1 over tan x. Again, this is the quotient because there's a fraction. So the function on top is u, and the function down is v. Alright, now without wasting time, applying quotient rule says dy over dx. Let me try to create space. Which says dy over dx is equal to v du minus u dv all over v squared. Okay, are we there? Are you with me? Are you with me? v du minus u dv over v squared. And we all know what v du means. Hold v differentiates u, and then u dv means hold u differentiate v. So let's get the part started. Now, if I hold v is tan x. In a bracket, I will differentiate u is 1. If I differentiate 1, I will get 0 because 1 is a constant. Minus. What am I holding now? U. What is u? 1. But what am I differentiating now? V. What's v? Tan x. When you differentiate tan x, you get sec square x. Sec square x. All over. What do I have down? V. Now what's v? Tan x. So here becomes tan x raised to the power of 2 because of the power of v in the formula. Now without wasting time, let's open the brackets. Tan x times 0 gives us 0. So there's no need for us to include 0 in the math because 0 is nothing. Then equals to minus 1 times sec square x will give us sec square x over, what do I have now? I have tan x raised to the power of 2. Now let me explain something to you here. Watch. In this situation, on top we have sec square x minus sec square x, and down we have tan square x. If I should expand this mass, we are going to get something like this. Minus sec x over tan x times sec x over tan x. Yes, that is what we're going to get. Because this square shows that sec x is 2 times. This square also shows that tan x is 2 times. So we have expanded the mass. But don't forget that sec class is the inverse of cos. 1 over cos. Sec is the inverse of cos. So it means that anywhere I see sec x, I'm going to include what? 1 over cos x. 1 over cos x. So in this case, here becomes, but there's a minus sign here, don't forget that there's a minus sign at the numerator. So here becomes minus 1 over cos x tan x. Yes, and then you'll be wondering, how did I get that? How did I get that? It is very simple. We said sec is 1 over cos. This 1 is the 1 here. The minus is the minus with sec. Then the cos is the cos down. Don't forget that sec was actually carrying the tan at the denominator. This is the tan here. So they multiply each other because you now have two denominators. Now, also times, here also remains, if sec x is 1 over cos x, it means here will become 1 over cos x again, then tan x. Are you with me? Are you with me? Now, without wasting time, back again to trigonometry. In trigonometry, sine x is equal to, in trigonometry, tan x is equal to, I want to prove out something, tan x is equal to sine x over cos x. Now, if in this equation, we want to make sine x the subject of the formula, it means I will base tan x over 1. And then I will cross multiply. Are we there? Now, sine x times 1 gives us sine x, and tan x times cos x gives us tan x cos x. Now the class, come on, watch. What do I have here? Cos x tan x. What do I have here? Tan x cos x. They are the same thing. It's just like saying x y, y x. They are the same thing. So it means that anywhere we see cos x tan x, what are we going to put? Sin x. Sin x. So without wasting time, here becomes minus 1 over sin x times 1 over sin x. Are we there? And we said that 1 over sine is the inverse of what? 1 over sine is the inverse of sine. And the inverse of sine has a name. What is the name? Cosec. What is the name? Cosec. Now the full name is called cosecant. So it means anywhere I see minus 1 over sine x, I will say minus cosec x. Times 1 over sine x is just cosec x. Are we there? And minus cosec x times cosec x will give us minus cosec square x. Class, this is the answer to the question when we differentiate cos x. So class, we have come to the end of today's section, and I believe that you have learned something new today. Please don't forget that after learning, you have to practice, because when you practice, you become perfect. If this is the first time on joining our channel, you're welcome again. Please don't forget to subscribe, don't forget to like our videos, don't forget to share our video. Most importantly, share our videos so that it can go across the globe. So we'll meet again in our next video. Always keep on reading. Bye for now.